Today what we're going to talk about is the properties of exponents. There are about 6 properties that we're going to deal with. The very first one is the product of powers. Exponents. Alright, and what that means is product lets us know we are multiplying. Now, it is confusing for some because when they think of product, they think they have to multiply. Exponents tells us that we are working, if we have this right here, exponents lets us know that we are working with this number that's higher than the constant, which is right now my a. Alright, so when it says product of powers, what we're going to do is we're going to say, okay, well what if I want to multiply a to the 5th power times a to the 4th power? Alright, even though it says multiply, when it is separated by a multiplication symbol, whether it is the dot, which is what you see today, or a time symbol, which is what you will see in scientific notation, all that means is that you are going to add the exponents together. So therefore, we have a to the 9th power, and this is your answer. If you have a number, say this was, and I'll make it smaller, 2 to the 3rd times 2 squared. Alright, again we add because of the multiplication symbol. 2 to the 3 plus 2 equals 2 to the 5th. But when you have a whole number, you don't leave it in exponent form, you solve. So that becomes 16, 20, no, 32. 32. Because it would be 2 times 2 times 2 times 2 times 2. In the power of powers, you will normally see it, and I'll put, you will see it when you have an exponent, then a parentheses, and then another exponent. When you see a parentheses separating 2 exponents, you actually multiply. So therefore, you end up saying 5 to the 2 times 3 power, which gives you 5 to the 6th, and again you would solve. When you have a power of a product, when you have 2 inside of parentheses, 2 or more inside of a parentheses, you're basically distributing the exponent into everything inside the parentheses. So you rewrite it m cubed n cubed. And that's what you would do. Again, if you plug in numbers, then it would be 2 cubed times n cubed, which is 8n cubed. Because anytime you have a whole number, you do not want to leave the exponent. Now, on this one, again, it's a power of a product, but you can see that we have multiple things that we have to distribute. It's not just to variables, and it's not just to constant numbers, but you distribute it to everything in the parentheses. So, and I like my arrows, so I don't forget. So I'm going to rewrite 3 cubed. And again, because this is separated by a parentheses, even though it's not right beside the parentheses, it's still separated by the parentheses. So this becomes n to the cubed times 3. And then we still have distributing to my x. So x to the 2 times 3, and then one last time, times 6 cubed, because you distribute it all the way. All right, I do that before I do any solving, so I do not forget to distribute to everything. Once we get to this point, you want to go ahead and solve. I know 27, 36 times 3, 18, is that 108? I think it's 108, times 108, because all I'm doing is moving this up here. Oh. I moved it to right here. All right, because I want my whole numbers together. Then I do n, 3 times 3 is 9, x, 2 times 3 is 6. And then again, this right here, 27 times 108, you would put it in your calculator and solve. And that would be your answer. In a negative exponent property, anytime you see a negative, no matter what, you know that just know that you're going to have to move it. All right? If we start with a to the negative 3, all right, the very first thing I do, me personally, is I put it over 1. Any whole number can be put over 1 to make it still be a correct statement. Now, when you see a negative, what that means is you have to move this to get rid of the negative, to cancel out the negative. You have to move this whole part that's negative underneath. And so it becomes 1 over a cubed. Because that's the only way to get rid of your negative exponent, is to move it. Now, if we had one that gave it to us as, if we had 1 over b to the negative 3, you're doing the same thing. Because you see a negative, you have to move it. So this time we're going to move it up. This goes here, and so it goes to b cubed over 1, or just b cubed. If there's ever any doubt when you see a whole number, because there are a lot of times people don't realize that you move it to a denominator, just make your whole number into a fraction to begin with. And you can make any number into a fraction by putting 1 underneath it as the denominator. Zero exponent property. Simply says that if your exponent is 0, your answer is always going to be 1. It doesn't matter if it is a variable like my a. It doesn't matter if it is 4, it still equals 1. Any number or variable, with the exception of 0, every other number out there, it becomes 1. Any unknown to the 0 is a 1. All right? The quotient of powers property says if you have an exponent on the bottom and the constant numbers are the same, like my two a's, I subtract the exponent from the bottom from the top. So I can rewrite this as a to the 4 minus 2. And so when we simplify, it becomes a squared. Now, if for some reason I have it to where you have a to the 4th, but then you have a to the 6th, all right? And you will see this a lot in homework and stuff. We do the same thing. Remember, you subtract bottom from top. So a to the 4 minus 6 that gives me a to the negative 2. Because of this right here, it brings back our negative exponent property. There are going to be many times when you use more than one of these properties in one equation. Because now, because of this answer, it now becomes, I can put it over 1, and my answer ends up being 1 over a squared. And in this one equation, I've used two properties in one. What you will see for scientific notation is something in the form of this. It might say 1.4 times 10 to the third, and it might say 1 times 10 squared. All right, anytime you see a single digit with a decimal and numbers after it, and then times 10 to a power, you're looking at scientific notation. Now, there are different ways to solve this, but the fastest method to solve this is to redistribute, move this 1 into this, and move this 10 into here, because you get like terms in the same parentheses. So I'm going to rewrite as 1.4 times 1 in one parentheses, and then the second parentheses I have 10 cubed times 10 squared. All right, from here you can actually solve using our exponents, the property of the exponents, because it's separated by a multiplication symbol. So that lets us know that we actually add 10 to the 3 plus 2. And then we have our 1.4 when we multiply 1.4 times 1. What you have left is 1.4 times, because remember, two parentheses side by side means multiplication, 10 to the 5th. And there is your new scientific notation answer. We're going to work a scientific notation problem, and you can see that it is a fraction. So, and you can see that we have exponents, so stands to reason that we are going to be using one of the quotient of powers, quotient of exponents property. The first thing I'm going to do though is I'm going to go ahead for my numerator, which is the top, I'm going to combine into one set of parentheses my whole numbers, which I'm going to circle. All right, so I'm going to rewrite 7.5 times 4.5. That covers my whole numbers. Then I'm going to, in the second parentheses, I'm going to do my exponents, which are my squares. 10 to the 8th times 10 to the negative 4. All right, then I'm going to go ahead and keep it over 1.5 times 10 to the 7th, because all I've done is rewritten. Now, once you rewrite it, then you can start doing your math. All right, I like to go ahead and do what I can first, which is this, and so I'm going to do 7.5 times 4.5, and that gives me 33.75. And based on what we have done, when it's separated by a multiplication symbol, there are two ways you can do this. The first way is to go ahead, because we see this negative, we can go ahead and move it down here and make it a positive. Or you can leave it up here, because we know that when they're side by side separated by a multiplication symbol, we add them together. For that reason, I can say, okay, well, if I go ahead and add them, instead of moving first, I'm going to say this gives me 10 to the 4th power. So right now I have a positive exponent. Then I'm going to go ahead and leave this as 1.5 times 10 to the 7th. All right, now, the next thing I want to do is I want to get my 10 to the 7th gone. I want my exponent gone on bottom, if at all possible. So for that reason, I'm going to say, now I have 33.75, over 1.5 times 10 to the 4 minus 7. Because again, we subtract bottom from the top. All right, at this point, I'm going to go ahead and solve the 33.75 divided by 1.5, and that gives me 22.5 times 10 to the negative 3. All right, but we're not done, because scientific notation means that you have one digit, then a decimal, and right now we have 2. So in order for us to get to one digit, we're going to move left 1, move the decimal left 1, but because we moved it to the left 1, we have to add one exponent. Therefore, our answer is 2.25 times 10 to the negative 2. And this is your answer. Anytime you have more than one digit in front of your decimal, you have to move your decimal to the left until you get to one digit. And however many times you move the decimal, you have to add it as an exponent.